suppose say ym and yn, these are the solution of your Sturm Liouville's problem, and these are you known as these are the eigenfunctions. These are, suppose these are the solution, and you know that these are the eigenfunction. These are the eigenfunction of boundary value problem. Okay, suppose this boundary value problem means equation 1 and you take equation 2. Okay, so these are the eigenfunctions corresponding to your eigenvalues, and these eigenvalues are distinct one. So this is the corresponding distinct eigenvalues. Suppose lambda m and lambda n. Okay, so if these are the eigenvalues, suppose lambda m and lambda n. Okay, so if these two are eigenvalues and these are the eigenfunctions, so you have to prove that this eigenfunctions yn and yn, these are orthogonal. These two eigenfunctions are orthogonal with respect to any weight function. So with respect to the weight function, and that weight function, that is say Rx. Okay, so here the proof is very simple. So here in this case, you know that what is the value of this T of these two eigenfunctions, say yn and ym, if x is belongs to closed interval AB, and you know that is equal to this PV of y and b, and the derivative of second at this endpoints, and minus Roskian of that. This means yn prime b with second eigenfunction at this endpoint. Okay, so this is your first one. Okay, and then this minus with second minus endpoint, this is your lower limit, this is PA. Okay, so you have to find what is the value of at this Roskian of that at that point. So yn a and ym prime a minus yn prime a and ym prime a. Okay, so these are the values. Okay, so this expression here, you check that this is 0 once we use the periodic condition, that is 3. What is your condition 3 is there? Okay, so you know that from equation 3 and this equation 3, basically equation 3 is your periodic, okay, boundary condition. Okay, this is your periodic boundary condition, and in this boundary condition, you know that ya equals to yb, okay, and y prime a equals to y prime b, and pa equals to pb. Okay, so in this equation third, you have already this pa and pb are same, and the functional value at endpoints, this is also equal, and the derivative of that at also equals to that point. Okay, this is the periodic boundary condition. So if we using this equation 3 of this boundary value problem, so here if we putting these value, so this equals to 0. Okay, so this equals to 0. This equals to 0. This means this the expression, that expression inside the bracket is 0 if we use the periodic boundary condition. Okay, so So if you use periodic boundary conditions, that is equation 3. Okay, so you can write this thing. So here the proof of this theorem holds. Okay, so now in next page there are another theorem in which it says that if this theorem holds, and suppose this parameter, this RS parameter, that is your either positive or negative in that closed interval AB, and of course this is the continuous function on that interval. So you have to prove that then all eigenvalues of that boundary value problem are real. Okay, यदि आपका कंडीशन फर्स्ट होल्ड करे और आपका ये आर जो पैरामीटर है दैट इज आइदर पॉजिटिव और नेगेटिव ऑन दैट इंटरवल एंड कंटिन्यूअस, देन योर आइगन वैल्यूज आर ऑलवेज योर रियल वन. ओके, सो नेक्स्ट पेज the next theorem says that, so next page, so here this theorem says that let the hypothesis of theorem first, this is hold, and if you suppose that this R means Rx. Okay, so if this Rx is positive on the given interval AB, or you can say this Rx is negative on this interval. Okay, so and your Rx is continuous, this is continuous function on, of course, the given interval. So you have to prove that all the eigenvalues of the boundary value problem. Boundary value problem means equation first and equation suppose 2a, or equation first with equation 2b. These are real. Okay, so this boundary value problem or this is always, these are real. Okay, so proof, you prove let us start with our eigenvalues are not real. Okay, so if we start with this lambda, that is eigenvalues, and suppose this is not real, so we can take this is in the complex form. So this be
sir, so equation 1 के बाद क्या लिखा है? R real, उसके पहले क्या है? लास्ट थर्ड लाइन में यहाँ यहीं पे हाँ, इसके पहले
R real.
R real के पहले equation 1 के बाद
equation 1, equation 2, this is or this boundary value problem, then all the eigenvalues of boundary value problem.
अच्छा, 2b जो लिखा हुआ है क्लोज ब्रैकेट में वो पूछ रही है.
Equation 1a or equation 1 and equation 2b.
ओके सर.
ओके, इक्वेशन 2 में हमने डिफाइन किया है, आप नोट्स को आप देखें, इक्वेशन 2 में हमने दोनों बाउंड्री कंडीशन के लिए जो m1 m2 m3 m4 के फॉर्म में लिखा है, तो दैट इज योर इक्वेशन 2a एंड 2b. ओके, एंड कंबाइंड फॉर्म में हम इक्वेशन 2 कहेंगे. ठीक है, तो बाउंड्री वैल्यू प्रॉब्लम अगर इस तरह से है आपकी, तो यहाँ हम यूज कर रहे हैं कि लैम्डा बी एनी आइगन वैल्यूज. सो इफ यू यूज दिस इज योर आइगन वैल्यू. ओके, एंड लेट your eigen function, if this is your eigen value, then eigen function is of course continuous, of course is imaginary if you take lambda be the imaginary one. So this is of this form. Okay, so this be corresponding, this is the corresponding eigen function. So this is your corresponding eigen function, and where What is your A and B? So here A and B, A, B, and what is your MX, NX? All are real. So here M, N, all are real. Okay, so are real one. Okay, so from equation one, if we take our equation one, and we have, what is your equation one? Equation one says that this is you know that this p y prime plus q y plus y prime. Okay, so this becomes okay. So this becomes m plus n. Okay, so this equals to plus I think you can write here lambda ry, that equals to 0. So this is your equation number one. Okay, from equation number one you can write this form. Okay, so okay, so here I think this q of y. Okay, so this is not y prime, this is q of y, because in this term if we differentiate this, so we got this prime plus this. Okay, so here this is only qy plus rxy. Okay, so okay, so if you're putting here in place of y is this thing, and okay, and lambda equals to a plus ib, so we get here, we get this equals to this p of m prime plus I n prime whole prime, then plus q, this is a y means m plus in, and plus lambda is a plus ib of r, and then y is m plus in. Okay, m means mx, and this is nx. Okay, mx plus nx. Okay, so this equals to 0. So if this satisfies your equation number one, because this is the solution corresponding to that, this is the solution of eigenfunction corresponding to this eigenvalue, so this must satisfy your equation number one, and equation one says this thing. Okay, so here if we're equating real and imaginary part, so if we're equating, so
सर ये जो फर्स्ट टर्न है उस पे से पी तो बाहर होना चाहिए ना?
किसमें किसमें पी बाहर होना चाहिए?
सर ये वाला यहाँ पे सर आपने y प्राइम की वैल्यू पुट की है, तो सर m प्लस आई एन.
ओके ओके, यहाँ भी पी होगा. ओके ओके ओके, हम यहाँ पे पी लिख देते हैं. दिस इज आई एंड दिस इज पी. Now it is correct. Okay, here p into this thing. Okay, so you have to multiply p here and p here, because y prime equals to m prime plus I n prime. So if you multiply p here, okay, thank you. Okay, so if equating the real and imaginary part, equating the real and imaginary, so you get this p of m prime, this prime. Okay, this is real part. So this plus q here, this is m, qm, and here from this one you get arm. Okay, so this becomes q plus am ar. This is q plus ar, and both multiplied by m here. Okay, both multiplied by m here. And from this minus I and minus I, this was I and I square. This was minus 1 brn. Okay, this is minus brn. So this is your real part, and what is your imaginary part? This one, this becomes p n prime whole prime. This plus imaginary part here qn, and here this n and r and a. So this becomes q plus ar of n. Okay, and then what is the imaginary part here? If we multiply these two, I of that, so this is I b rm. So this I BRM. So that's equals to 0. So here we equating imaginary and real parts. Okay. So now look here, this is Q plus ARM and here Q plus ARN. So if we multiplying here N and here M and subtracting these two, we eliminate this term. Okay. So if we elimination of, if we write here, if we elimination of this term Q plus AR in the above two equations, the above two equations, okay, implies you have, if you multiply here, okay, so this becomes n. So this term is minus BRN square, and this is plus BRM square. So if we m square plus n square with this BR, now subtracting this, so minus and minus. Okay, so this becomes minus B m square plus n square into R. Okay, and that equals to here in this term we multiply n, here we multiply m. Okay, so if we move it to right hand side, so this becomes sign a change, so this becomes m, and here p n prime, this means, okay, p n prime whole prime minus this term, if we multiply it by n, so this becomes n p m prime whole prime. Okay, so you can write this equals to d by dx of d over dx of this term, and this term is equals to okay, so this term is you can write p n prime m minus p m prime into n. Okay, so here, because if you adding and subtracting this term, because this first function differentiation of second. Okay, so look here, ऐसा आपने पहले भी कर चुके हैं, इसलिए हम इसको डायरेक्ट लिख रहे हैं, ये चीज आपने किया भी है। तो इसका डेरिवेशन क्या होगा सब, इसका डिफरेंशिएशन दिस प्राइम m, तो ये टर्म आएगा, देन प्लस m प्राइम दिस थिंग। ओके, यहाँ पर भी आप देखें तो m प्राइम n प्राइम p यहाँ भी आएगा। अगर आप इसका डिफरेंशिएशन करते हो तो दिस बिकम्स, इफ डिफरेंशिएशन ऑफ दिस, तो दिस प्राइम इंटू n ये टर्म आएगा, और अगर हम इसकी डिफरेंशिएशन करें p m प्राइम n प्राइम, तो ये प्लस और माइनस दोनों क्या होंगे, कैंसिल होंगे, तो ये टर्म आ जाएंगे। ओके, सो नाउ अगर आपको देखना ही है तो हम इस टर्म को हम ऐसे लिख सकते हैं कि व्हाट इज द मीनिंग ऑफ दिस, तो दिस मींस d ओवर dx ऑफ p n प्राइम इंटू m माइनस p m प्राइम इंटू n। इसकी वैल्यू क्या होगी, दिस इक्वल्स टू फर्स्ट फंक्शन की डिफरेंशिएशन m प्लस this first function into differentiation of second, and माइनस के साथ इसमें देखें तो इसकी डिफरेंशिएशन क्या होगी, p m प्राइम n, एंड देन प्लस, तो माइनस साइन है तो यहाँ भी माइनस p m प्राइम, और डिफरेंशिएशन ऑफ सेकंड इज n प्राइम। तो आप देखेंगे तो ये टर्म जो है हमारे और ये दोनों टर्म हमारे कैंसिल हो जाएंगे। तो सिंपली दिस term and this is your term. Okay, that's why we can write in this form. क्यों लिखा, क्योंकि now we can easily integrate this term. Okay, so in next page if we integrating this equation with the limits are capital A to B, because this function is defined over this closed interval AB. So now if we integrate this integration of that with A to B, so this becomes in next page you can write okay, so next page, so thus by integrating we get uh, this is minus b because this is the constant, because this is the imaginary part of your eigenvalue, so this means a constant one, so we take out from that integral, and this is m square. This is function of x, like in here we take here integration a to b, so we change this variable for any other variable, say s. Okay, so here we can write this is okay in this form. Okay, so this m square plus n square into r, of course r terms is there. Okay, sorry, so we put this into this rx and ds. This is your left hand side. Okay, this is your left hand side. Okay, at right hand side, if we integrate that term, so this is simply p n prime into m minus p m prime into n. Okay, and this is limits are a to b. Suppose this is say equation star. Okay, so here m and n, these two that satisfies one of the boundary condition, say 2 or 3. So we have as shown earlier, we can write here this p 2a or 2b. Okay, so here we can write here, this is boundary conditions. This is 2a or 2b. Okay, so you can already we have shown that this this p of n prime n minus m prime n, this is the Roskian of this mn, so p of w Roskian of that a to b, and this equals to basically p of Roskian, that is mn on that interval ab. You have already proved that equals to 0 always. Okay, so this means this Roskian of mn, and this is nothing but this equals to this thing. So this is your the Roskian of mn. Okay, so here you can already prove that if this satisfies your condition 2a or 2b, so this must be equals to 0. Okay, so here suppose if we take this is another equation, and if we relate these two. Okay, so here this integral, that integral is this minus b integral a to b, and m square plus okay, so you know that okay, so you know that this m square and n square, and this is not equals to 0, so you have also another condition, that is this m square s plus n square s. These are okay sum of this quadratic proof function with rs, and rs is not 0, because in your assumption in your theorem statement is already given that this rs may be greater than 0 or less than 0 in this interval. So this is a non-zero term, and these are the square summation of two square term. So this never 0 in this closed interval AB. So if we integrate that term, this is not equals to 0. Okay, so this is already given by your assumption. Okay, so this is by assumption in your theorem. Okay, so this is given your RS is this thing, or RS is less than 0 on this interval AB. Okay, so that's why this is never 0. Okay, so if we take this equation that equals to 0, and this portion is non-zero, so this means this B equals to 0. Okay, so hence we conclude that from equations, that equation are star and say double star. Okay, so it follows that follows that this b equals to 0, because this is 0 and this is non-zero, so here b equals to 0. So b equals to 0, so which means your lambda that equals to a plus ib and imaginary part are 0, so which means that your lambda is real. Okay, so this means your lambda is real because this imaginary part is 0. Okay, so this is the gist of the theorem, because if our weight function is either greater than 0 or less than 0 in that domain, so our eigenvalues always real one. Okay, so okay, so there are two more theorems. First one on which we define the Roskian of that two are constant, basically when this q part is 0. Okay, so okay, so okay, so next page हम थ्योरम ही लिख देते हैं पूरी क्या. So in next page, okay, so there are two more theorems. I think theorem 5, that is 6. Okay, and this is small theorem basically. Okay, so after that we go through the problem. Okay, so here this theorem says that if two eigenfunctions, suppose phi1 and phi2 are any two solutions of if you write in short form Ly plus lambda Ry that equals to 0, where what is L is basically d over dx of p d by dx plus q. Okay, so if we operate that y, so this p by dx of that y plus qy. Okay, so this if these are the two solutions, then what is the value of this px and Roskian of that two solutions, that is phi1 and phi2. Okay, so what is the value of that? Okay, so this is always constant. Okay, so here nothing a to b are given. Okay, so if only if there are general solution, if phi1 and phi2 are two solutions of this Sturm-Liouville's boundary value problem, then the px of this Roskian of these two solutions must be constant. Okay, so here the proof. So proof is very simple. You have to only put that solution in your given Lagrangian Sturm values solutions. So here we have d over dx of p d over dx. Okay, and there are two solutions, phi1 and phi2. This means this satisfies your main equation. So here you can write here phi1x plus q phi1x, and this is lambda r phi1 x that equals to 0. So this is equation number 1. Okay, similarly the second phi2 is also the solution of this Sturm-Liouville's boundary values problem. So you can write this is phi2 with q phi2x plus lambda r phi2x, and that equals to 0. This is your second equation. Okay, so now if we have to eliminate this term, so here we multiply here we multiply in this equation. Suppose these are the phi1, so we multiply here phi2x, and here we multiply phi1x, and subtracting these two. Okay, so here from the above equation, so from equation first and second, we get okay. So if you multiplying and then subtracting, so you get okay. So we can write here okay. So from okay, so here we write this thing. Okay, so multiplying 1, here we can write completely here. So multiply 1 by this phi2x, and equation 2 by phi1x, and then subtract. Okay, and after that integrate it from initial point to a general point x. Okay, so we get here, if we integrate for any a to general x, then if you multiply here this phi 2 of phi 1, and this is phi 1 phi 2. Okay, so this can be written in this form. This is phi 2 multiplied by that. This is a d over dx. This is p d over dx of phi 1x minus here we multiply phi 1x. This becomes phi 1x d over dx p d by dx of phi 2x, and this is integrate over with respect to, okay, sorry, here not, this is a function of x because this is the limit of x is given. Okay, so you have to change this is the function of s here. Okay, so this is d over, okay, so okay, so you have to change that is okay, so suppose if you write dx here. Okay, so this equals to 0. This equals to 0. This equals to 0 because if you multiply here phi 2 to this lambda r phi 1 phi 2, this is lambda r phi 1 phi 2, these are cancelled out, and this term is also cancelled out. So these two are considered simply this term. This term is given. Okay, so here okay, so here this x is simply your s. Okay, so we can write here this is your s here. Okay, so this is s because we can write here x. Okay, so this is s. This is s. So try to rewrite. This is the function of s. Okay, so this equals to 0. This equals to 0 means we have to calculate this term, and that equals to 0. Okay, so here the first one here we have this phi 2 and okay, phi 2 d by dx of that term. So this becomes px and ps. Okay, this is ps. This first one, this is ps function of s, and derivative of that is absent. So this becomes phi 1 prime s, phi 1 prime s, and limits are a to s. So a to s, limits are a to s, minus for second one. Okay, so integration of that, and minus integration a to x. Okay, so I think we have to go to next page. So okay, so next page पे हम चलें, ज़्यादा बेहतर है. तो next page पे हम चलते हैं. Okay, so next page we can write this is phi 2 ps phi 1 prime s, and limits are a to x, then minus a to x. This is phi 2 prime ps and phi 1 prime s ts, and minus for second term के लिए हम लिख सकते हैं कि minus okay, so this is your first term. Okay, and second के लिए हम same तरह से लिख दें, तो this becomes phi 1 integration of second, that equals to p, and this is d phi 2 by ds. This is phi 2, this ps, this is p function of s, and this is phi 2 prime s, and limits are a to x, and then minus and integral a to s, and this one phi 1 prime ps. We have to only this simple integration. You have to solve this integral. This is phi 2 prime s, and this is ds. Okay, and that equals to 0. So this implies you can write phi 2 ps phi 1 prime s. Okay, and limits are a to s minus a to x phi 2 prime this ps phi 1 prime s ds minus phi 1 ps phi 2 prime. This is a2x and this is minus and minus plus.
सर वहां पे सर लिमिट a to x होनी चाहिए ना एकदम स्टार्टिंग में सर इसी लाइन में।
हाँ क्या होना चाहिए
सर जो लिमिट है a to x होना चाहिए ना।
a2x ओके ओके सॉरी सॉरी देखिए ये गड़बड़ी है ऑनलाइन में जो है। खैर चलिए कोई बात नहीं। तो आप ऐसे जहां भी हो हमें आप करेक्ट करते जाएं। हाँ ठीक ठीक। तो इसमें हम देखें दिस इज phi 2 prime phi 1 prime ps that term is a2s minus sign plus sign. So these two terms are same, so we cancel out these two terms. Okay, so simply we have if we take this point, so here after okay, so here px are same, so we can write here phi 2 ps phi 1 prime, this is a2x, and second one is minus phi 1 ps phi 2 prime s, and limits are a2x here, and that equals to 0. That equals to 0. Okay, so if we putting here the lower limit a, if we putting here lower limit x is there, so this becomes px. Okay, and if we put here this is lower limit, so in that sense okay, so we can write here px be the common, so this is the px, and that are the phi 2 s and phi 1 prime x minus that equals to okay, this is phi 1x and phi 2 s, that is a2x there. Okay, so this equals to 0, this equals to 0. So this means you can write this equals to okay. So this the limits are a to s. This limits are okay. So this is ps, and this limits are a to x, that equals to 0. Okay, तो अब हम क्या करें, एक बार s की जगह x पुट कर लें और जगह a पुट कर लें. Okay, so this implies you get px, and here phi 2x phi 1 prime x minus phi 1 x phi 2 prime x. Okay, this thing, and minus of a, तो minus इधर है तो उसको right hand side ले आए, so that equals to p of a phi 2a phi 1 prime a and minus phi 1a and phi 2 prime a. Okay, this thing. Okay, so
सर क्लास स्टार्ट हो गई सर उधर।
क्लास स्टार्ट हो गई, बस 2 मिनट तो बस 2 मिनट, बस इसके आगे हम अब नहीं कर रहे हैं. तो ये देखिए राइट हैंड साइड में क्या है, राइट हैंड साइड में आप देखें राइट हैंड साइड में क्या है कि p फंक्शनल वैल्यू एट एनी कांस्टेंट पॉइंट, सो दिस इज द कांस्टेंट वन. ओके, सो दिस इंप्लाइज योर px phi 2x phi 1 prime x minus phi 1x phi 2 prime x, that equals to here this term is constant. This is constant. So this is constant. So that why you can write here this is a px, and what is this thing? This thing is Roskian of phi 1x and phi 2x. So this equals to constant. This is constant. Okay, so you can write here because this is the Roskian of that. Okay, so this is your constant, and you know that this is this known as Abel's formula. This is your Abel's formula. Okay, so here if px of Roskian of that equals to constant, so you can show that thing. Okay, चलिए फिर क्लास स्टार्ट है आपकी, तो आप क्लास करें. ठीक है, फिर नेक्स्ट क्लास हम मंडे की होगी. मंडे हम आपको इसके आगे कराएंगे, न्यूमेरिकल भी हम मंडे को ही करेंगे. ओके, चलिए ठीक है. जल्दीबाजी में आज एक क्लास हो गई, वैसे हमारा शेड्यूल 4 बजे था, लेकिन चलिए ठीक. ओके, थैंक यू टू ऑल.
थैंक यू सर.
थैंक यू सर.
थैंक यू सर.
Thank you, sir.
ओके,
थैंक यू सर.
थैंक यू.